We have a series, and we want to find out if this converges or diverges. So it's clearly an alternating series because we have this here, so naturally we're going to use the alternating series test. With the alternating series test, we have two different conditions. If it meets both conditions, then we can say that it converges. Only if it meets both conditions. If it doesn't meet both conditions, then we can't say that it converges or that it diverges. It's inconclusive, and we would have to do another test. So first of all, we want to make sure that b sub n is decreasing. B sub n is decreasing. So in other words, b sub n plus 1 is less than or equal to b sub n. And if we differentiate, then this would be negative. Negative derivative. So either one of those things, you just have to make sure that b sub n is decreasing, and you have to make sure that the limit as n approaches infinity of b sub n would give you 0. Those are the two things you want to make sure of. So for the first one, we have to show that it's decreasing, no matter how you realize or show that it's decreasing. So with ours, we could do the first style, which is to have b sub n plus 1 is less than b sub n. So let's check if it is indeed less than b sub n, because that would show that it's decreasing. So what happens if we have, by the way, b sub n is the part without the alternating part. So sine of pi over n is b sub n. Is this greater than b sub n plus 1? B sub n plus 1, we plug in n plus 1 wherever we have an n. So would this be less than? So it doesn't have, first of all, it doesn't have to be less than this for all terms that you plug in. It has to be less than this one for all the terms that matter. So for pretty much most terms. So if for the first 100 terms, this isn't less than, but then for all other terms until eternity, it is less than, then we still say that it's going to fulfill our criteria. So pretty much we just need to make sure that it always does, even if for the first few terms it doesn't, for the first few terms of the series. So that's the first thing we have to get clear, that it doesn't have to be for all. So let's plug in our first term. That would be sine of pi over 2, because we're plugging 1 into there. Is that less than sine of pi, and then we plug in 1 in there, which is sine of pi? Well, in this case, no. In this case, no, because we have our circle. That's really bad. That's really bad. That's still very bad, but it's a little better. I don't know what's wrong with me right now. I don't know what is wrong with my brain. Okay, that's a little better. So the point is that sine of pi is over here, which yields a value for sine of 0. And pi halves would be right here, pi halves, which would give us a value of 1 for sine. That's the sine value when we plug in pi halves in the way that we did. So in this case, this is 1 and this is 0. So clearly, this is not true. This is not true. 1 is not less than 0. But what happens if we plug in 2? If we plug in 2 into there, we would get sine of pi halves, and then we would get 2 plus 1 in the denominator, which is sine of pi thirds. So pi thirds would be over here somewhere, like maybe a little higher, like pi thirds, and so then that would yield a smaller value for sine. And then we plug in our next number, which is 3. That would give us sine of pi fourths and sine of pi thirds. So in that case, this would be larger than this one again, because this one would end up over here somewhere, like pi fourths. And then we plug in the next one. Now this is pi fourths, and this would be pi fifths. Pi fifths is obviously smaller than pi fourths, and so on and so forth. This would be 6, and this would be 5. So this would be this one. And so for all other terms, this is less than. It's just for the first one that it didn't. But infinity swallows the first term. It doesn't care about just one term. What we care about is the behavior as you go towards infinity. So it does meet the condition that this is true when you're considering infinity. When you're considering infinity, it doesn't matter that the first one just happened to not coincide with this relation. So we can say that it is decreasing. This is decreasing. And so now let's try our second thing to see if it really converges. We still have to pass another test, which is taking the limit as n approaches infinity, and so we know what's going to happen, right? We know what's going to happen because when we take the limit as n approaches infinity, that's what happens. You would plug in, you would have n here, and you would replace n with infinity. And so you would be taking sine of 0, because pi is just a constant divided by infinity would give you 0. Sine of 0, we know, was that region of the unit circle right there. It was right here. Sine of 0, that's 0 radians, and the value for sine is 0 right there. So it passes both tests, and therefore it converges.